All right, so check this out. It all started on one of those rare, quiet weekends. My wife and son were out of town, and I had the whole house to myself. So what do? I decide to solve a crime, a performance crime. Let's dive right into this case.
You know, every good detective story needs a crime scene. And mine? Well, it wasn't some dark, rainy alley. No, it was my MacBook Pro, just groaning under the weight of an absolutely insane amount of data.
And here's the evidence. Get this, a single text file, almost 15 gigabytes. Inside, 1 billion rows of weather data. The mission sounded simple enough. Read the file, and for each weather station, figure out the min, mean, and max temperature. Simple, right? Yeah, not so much.
So how long did my first, my simple Node.js script take? 5 minutes and 49 seconds. In the world of performance, that's an eternity. I mean, you could go make a coffee, maybe a sandwich. I knew right then and there this thing needed a proper investigation.
Okay, so my first big clue, my first hunch, it wasn't some crazy complex algorithm or anything like that. No, it was way more fundamental. It was about strings. I had this nagging feeling that the real culprit was hiding in plain sight, something everyone overlooks.
So here's the deal. The key thing to understand. The file itself is encoded in UTF-8, right? But JavaScript, it loves its UTF-16 strings. Now what does that mean? It means that for every single one of those billion lines, my code was doing this expensive, time-consuming conversion. My whole theory was, what if I could just skip that? What if I could work directly with the raw bytes? That had to be a huge win.
And this right here, this was the trick. Instead of parsing a string like 12.3 and dealing with messy, slow floating point math, I just treated the whole thing as an integer. I'd read each number byte, turn it into an integer, and just multiply by 10 as I went along. So 12.3 just became 123. Boom! No strings, no floats, just pure, lightning-fast integer math.
And the results? Oh man, they were good. I ran it on a smaller test file, just 10 million rows. The old way, 3.5 seconds. My new byte parsing trick, 1.8 seconds. We're talking almost 50% faster. But a good detective knows you don't stop at the first clue. The case was far from closed. So that first win felt amazing, but I just knew there was more speed to be found. The big problem was I was still converting all the station names into strings just so I could use them as keys in a map. And let me tell you, trying to solve that problem led me down some seriously dark alleys.
Man, I tried everything. I looked into string entering. Nope. Dead end. I tried using raw buffer slices as keys. Total disaster. Just corrupted all my data because of how JavaScript maps work. I even went so far as to build my own custom hash map from scratch. Hours and hours of work.
And you want to know what happened with my brilliant custom-built hash map? It was slower. Slower than the original code. It really just goes to show you sometimes the murder weapon is your own cleverness.
And then it was like 2 a.m. I was probably half asleep, and bam, it hit me. The real breakthrough. You know those moments where everything just clicks and the whole case snaps into perfect focus? The solution was just so simple, so elegant. Instead of turning the station name into a string, I just computed a 32-bit hash directly from its raw buffer. I used that integer hash as the key in my map. Think about that. I didn't create a single new string inside the main processing loop. The decoding, I pushed it all the way to the very end, after every single one of those billion rows was done.
So, the final time for the full 14 gigabyte file? 1 minute and 14 seconds. We went from almost 6 minutes down to just over 1. The case was pretty much solved, but I had to tie up one last loose end. I had to be sure.
Before I could officially close the book on this thing, I had to rule out any other suspects. I mean, what if it wasn't my code at all? What if Node.js itself was the real bottleneck? Was I just blaming myself when the runtime was the real culprit all along?
So I took the exact same optimized code and ran it on Bun and Dino. And what's super interesting here is just how close they all are. Yeah, Bun was a little faster, just over a minute, but look at that. They're all in the same ballpark. We're talking seconds of difference. And that was all the proof I needed. The bottleneck was never the tool. It wasn't Node.js, it was my code. It was the algorithm. And this is why, you guys, you have to be skeptical of those generic benchmarks you see online. Your specific problem is what really matters.
And for my final piece of evidence, I brought out the big guns, the profiler. And this right here, this was the smoking gun.
One single function, process chunk, was eating up 87% of all the time. It wasn't a memory problem. It wasn't a file I/O problem. It was pure, raw CPU bottleneck. My hot path was finally as clean as it was ever going to get.
So, what did this whole investigation teach me? Man, it was a total masterclass in hunting down bottlenecks. Let's just quickly recap the evidence. 78%. That's the final number. A 78% reduction in processing time. We went from a slow, painful crawl to an absolute sprint, and it was all because we thought like a detective and focused on the real evidence. So, let's break it down. We won by getting rid of all that string overhead, by using way faster integer math, and by being clever about when we actually did the work using hashing. But the biggest takeaway for you is this. Optimization is detective work. You have to come up with theories, you have to test them, and you can't be afraid to chase down a few dead ends to find the real culprit.
Okay, so we made the code 4.7 times faster on a single core. But remember that profiler? It told us we are completely CPU bound. One detective, no matter how good, can only move so fast. So, what's the next logical step to go even faster?
The next case? It's all about calling for backup. The next big win isn't going to come from more clever byte-level tricks. It's going to come from parallelization, splitting up the work across all the cores on my machine using Node.js worker threads. We're putting a whole team of detectives on this case.
And the best part? I'm already deep into that SQL, and let me tell you, the results are looking even more dramatic. We're talking about maybe, just maybe, cutting this time in half. Again.
This is where we get into the really advanced stuff, So if you want to see how we crack the case of multi-threaded performance in Node.js, you've got to subscribe to the channel. Trust me, you are not going to want to miss the next part of this investigation.